Hello, everyone. Welcome to Broadband Deployment News. We've got a lot of fiber in the ground, a lot of fiber optic cable, and even more is coming with BEAD funding. And you can do more than broadband with that. You can actually use that fiber optic cable or the fiber optic conduit and other fiber optic cables out there for long distance sensing for all kinds of use cases. Very interesting. Be right back with more. Thanks for joining. Rick Husey here with Broadband Deployment News. So looking at this article in Fierce Network, fiber optic cables can do more than just broadband. It turns out that fiber broadband isn't just a technology that delivers fantastic symmetrical speeds for internet connectivity, and not just fast speeds, but also very resilient. So, fiber has been out there for a long time. It tends to be very resilient. Obviously, you can have a backhoe and go cut something, but tends to be fairly good as far as low maintenance. Now that we've got installation down and fiber splicing, all those kinds of things, in much better shape than we had years ago, fiber optic cable is great for that as well. So the fiber optic cables can also act as giant sensors with use cases for public utilities, transportation companies, and smart cities. And there was a webinar recently that they are quoting from here. It says, I'm going to assert, and by the way, I linked to this article as well as to the webinar if you want to check it out on, I think it's a YouTube link if you want to check out the webinar. It says, somebody in the webinar said, I'm going to assert that the next big thing is, in addition to fiber to the home technology that we're deeply embroiled in, is distributed fiber optic sensing, said Paul Dickinson, chairman of the Fiber Optic Sensing Association, on a recent webinar hosted by the Fiber Broadband Association. Now, Fiber Optic Sensing Association, they are a nonprofit, not-for-profit, that is affiliated with the Fiber Broadband Association. So they are the ones promoting this fiber sensing. Dickinson is also director of business development at Orbia Duraline. He explained how distributed fiber optic sensing, or DFOS, works. He said optical fibers send pulses of light many times per second. While that occurs, DFOS can measure changes in the backscattering of the light when it encounters an unusual vibration, strain, or temperature change. So this is one of the slides from their webinar. So you see here kind of a description of what's going on. You see these silhouettes here. So these could be the kinds of things that it might pick up on. And if you've got fiber running alongside the road, it could pick up on a traffic accident. It could pick up on a backhoe that's near where that fiber is, so you could prevent it. You could find out beforehand that fiber is about to be cut, or maybe even some other utility line. You've got somebody digging there. That could be somebody just using a shovel. Could even pick that up. Can even pick up stuff like somebody opening a manhole or a handhole, where they could be there to steal something or for some kind of vandalism. So there's lots of different use cases for telecommunications company, utilities, and smart cities. So it sounds very, very interesting. And they provide some demonstrations of actually how this works in that webinar. So I would certainly check it out. Again, there's a link in the description of the video. So you see here, very long distances monitored at high spatial resolution in real time. Monitors the return signal for vibration, strain, and temperature around the fibers. That's what it can, kind of things that it can sense. So obviously vibrations, again, if you have a traffic accident, and it can monitor the road vibrations, and it can detect, if there's particular vibrations, then suddenly stops. So it could be just a single car going down the road, and then suddenly you've got something that sounds like a car accident, and then that car's not moving anymore. So it's going to use machine learning and eventually more sophisticated AI to be able to alert on what these things are. So in other words, hey, it looks like there was a car accident. It could be a very rural road, which they mentioned in the webinar, where you don't have cameras, and there may not be a lot of traffic, and somebody runs off the road, and it could pick that up, and you could dispatch emergency first responders there through the sensing capability. So it's really pretty powerful from the sound of it. Uses signal processing to automatically monitor, detect, and classify activity along the right of way, so wherever that fiber happens to be going. Reports to operators immediately with GIS, so you can see where it occurred on a map, and apparently pretty accurate, I guess, as far as location. And then actionable intelligence for response. So again, you can make a response there to that. So very, very interesting use cases. It says here, per sophisticated signal processing, you're able to automatically monitor and detect and classify not only the location along the fiber, but actually what's occurring based on libraries of information and in some cases machine learning and AI. With this information, you're able to report with GIS location exactly. So they use the term exactly. So I guess because you've got this very distributed long distance fiber and this sensing capability, and you're shooting the light down the fiber, you can then determine based on, again, the temperature changes, vibrations, strain on that fiber, that particular segment right there is what's being impacted. Yet it creates a very long distance, very long distance passive sensor with very high spatial resolution that's occurring in real time. In the case of a sound vibration, for example, you're able to detect with distributed acoustic sensing the acoustic activity that's many meters away orthogonally to the fiber along the entire length of the cable. So orthogonally, generally, you're talking about at a right angle. So I guess what they're saying there is if you think about a piece of fiber, let's say buried fiber, you've got things that could be happening on top of the roadway or wherever it happens to be, to the side, if somebody's digging to the side of it, where you're going to be able to detect that at a fairly accurate level as far as where the distance is, or where it is on the map, I should say. The sensing can continuously monitor things such as vehicle movement, digging activity, the health of bridges and railways, liquid and gas leaks, many other conditions. I know they use these in wells now. This is something that's already being used, and it's gotten better apparently as far as the accuracy of it and reducing the number of false positives, because obviously you're not going to really pay attention to something that's constantly alerting you that something's happening and it's nothing of significance. So apparently that's gotten better over time. He says here, a conduit and fiber cable that's previously been used just for telecom and broadband capabilities really just becomes a very valuable asset. Now he says here, fiber that's just been used for broadband. I don't know if this is something like if you're using that particular strand of fiber for broadband, I don't know that you can run the sensing over that as well. I was thinking, and I'm not totally sure. I'm thinking it would have to be another strand of fiber that you would use for the sensing. But if you've got the conduit there, it's not hard at all to run another piece of fiber through that to then use this sensing capability throughout that entire right of way. Fiber Optic Association is trying to get the word out so that fiber deployers are aware and can tap possible dual uses for their fiber. So I am helping them get the word out. So if you're any kind of operator, broadband operator, utility, it could be that you're just providing gas or water, or you could be a utility that's also providing broadband. But in either case, you probably have got fiber running already, maybe between substations, if you're an electric utility, for example, those kinds of things for monitoring anyway. And even if you don't, you could install fiber in some of these rights of way to be able to do this kind of sensing and really make a significant difference in outages, trying to prevent outages, being able to have a much faster mean time to repair on these kinds of things. If you can see something happening before that backhoe cuts your power cable, and the fiber along with it right next to it or near it. If you could get out there, warn somebody, or if you can determine that, hey, somebody opened a handhole that has got our equipment down in there, they could be going to steal copper or something else, or vandalizing that. You could then maybe alert. I think they were mentioning that this one guy that was on the webinar was mentioning that when that happens, they send a text to all their technicians that says, hey, something unusual is going on at this location, and I suppose the nearest technician can go take a look at that. Says we want to leverage not only existing brownfield fiber cable and conduit that's been implemented, but we want to start thinking about all the money coming through BEAD and others on how to design greenfield sensing in mind, or I should say, they probably mean how to design with greenfield sensing in mind. So that makes sense. So that, if you've got brownfield today, you've already got the conduit there, you can make use of that. But if you're thinking about not just the fact that you're going to be running this broadband, let's say middle mile network, something like that, you're going to be running this to take broadband from one area to another, maybe you direct some of that cable and that conduit to go, to take into account the fact that you're not just trying to get from point A to point B, but you want to use sensing between point A and point B, which means you may change the path that you go between point A and point B. Maybe you go past some certain things that you want to be monitoring. So that's pretty good suggestion there. Kyle Glazer, Vice Chairman of the Fiber Optic Sensing Technology Outreach Committee, said no industry is better positioned to support and benefit from the emerging DFOS technology than the telecom industry, as more fiber networks around the world position themselves as this multi-purpose network. And this could be good for, obviously, a fiber operator. It could be good for their own purposes as far as, again, realizing that, hey, somebody's about to cut our fiber, or somebody could be, again, vandalizing or stealing equipment, those kinds of things. But also, this is a service that you could sell to others over that fiber. So again, if you got that fiber running towards other, around other infrastructure, then you could be providing these kinds of, this kind of alerts and sensing capabilities to others. Glazer said most problems in gas, electric, and water utilities are caused either by damage from other construction work, such as digging and drilling, or by vandalism. He talked about some real-world examples of DFOS. He showed a video of an excavator digging too close to some above-ground utility equipment. Nearby fiber optic sensors detected the vibrations from the noise and sent an alert to the utility. In another example, someone opened a manhole in a street, and the fiber optic sensors detected the noise and notified the utility. So again, very interesting there as far as the types of use cases. And they, again, a couple of slides from their webinar. So you see here, they have emerging vertical markets. You've got utility uses, operational insight, damage prevention, security, preventative maintenance, benefits, obviously safety, resilience, third-party interference, minimization, operational expenses, transportation, traffic monitoring. So as you're seeing here, there's another slide on smart cities. A lot of this kind of works well with smart city initiatives. You've got traffic monitoring, situational awareness, rural insight, security, fire safety, structural monitoring. The benefits would be low latency ground truth data, enhance ITS portfolio, operational and capital expenses. Then you've got telecom, damage prevention, network monitoring, security, preventative maintenance. Benefits being network uptime and faster repair, security, monetization. A lot of these things apply to all of these. Faster repair for utilities, for example. The uptime for utilities, not having an outage when you could prevent that. And then mentions here the next big thing, in addition to fiber to the home, the big innovation push for fiber to the home and Internet of Things continues. The next big thing, smart infrastructure includes DFOS, converts dark telecom fiber around cities to an array of sensors. So again, they mention here dark fiber, so not fiber that you'd be using, let's say, for the broadband distribution itself. DFOS use cases to support smart cities, highways, real-time traffic monitoring, rail, train tracking, metro security, utilities, sewer integrity, power cable, fault detection, pipeline monitoring, facilities, perimeter security, structures, buildings, bridges, and tunnel integrity. Bridges is very interesting because, you're always concerned about any bridges that are getting old and that infrastructure, and I would see where maybe fiber optic cable could sense changes as trucks and cars go over bridges. It could probably sense maybe some things happening there with that infrastructure. Fire detection in tunnels, or I guess anywhere. If you've got a remote head end or something like that out there where you don't generally have people all the time, you could detect fires that way. You're going to have other sensors. I mean, you can have other IoT sensors, and you can have traffic sensors and cameras out there. But the point of this is that you've got this this long cable that you've got, just running from one place to another. So it's spanning that long distance, and it's there already, and you don't need to have sensors all over. I think the sensors, I think there's a distance in here that they mentioned. So you can do this over long distances without having to have, I think, lots of repeat sensors in the network. Another prime use case would be for traffic accident alerts. Glazer noted that there are already many long-haul and middle-mile networks along interstate highways, and this fiber could also be used as distributed traffic sensors. So again, distributed in the sense that you don't have to have sensors every mile or every how often you have to have it if it was a specific sensor that you then had to monitor. I said DFOS Interrogator can send pulses of light along the fiber for up to 45 kilometers in either direction. The technology can provide data about the speed of each vehicle on the road, and acoustic monitoring could record crashes. For the same route, it could also be monitoring adjacent utilities and other assets that are parallel to it in the right of way. This is truly a multi-use technology, said Glazer. Possible partners, organizations who might be interested in leveraging DFOS would be utilities, transportation companies, municipalities, right-of-way owners, and interestingly, dial before you dig call centers. The 811 Common Ground Alliance estimates that it costs $30 billion per year in infrastructure damage from digging. This technology is the only live technology that can provide preventative alerts to stop that damage from occurring, said Dickinson. He said Texas 811, and I think he mentioned in the webinar that's the largest in the country, that they have expressed an interest in FOSA technology. So not only waiting for somebody to call to let you know that they plan on digging, but maybe you can find out that somebody's digging, especially, again, large equipment, but even just anybody with a shovel. Apparently you could pick up that sensing and find out that somebody's digging near a piece of utility cable. If you've got fiber running if you've got all those cables running in that area, plus you've got that fiber sensing cable running there as well, and somebody's digging near their water pipes or their gas line or something like that, you could pick that up and alert the utilities, and maybe the utilities can then go out and check on what's going on. I don't know. Or maybe you contact that consumer. Maybe you make a phone call to the consumer and say, "Hey, that's kind of creepy, I guess, but hey, we understand. We see that you're digging in your backyard near your cable. A little bit creepy, but again, it's meant to prevent that damage, and I think it sounds like a great technology." So anyway, thanks for joining me today. If this was interesting, if you give me a thumbs up on the video, I'd appreciate it. And if you are not subscribed to our channel, go ahead and click the subscribe button. Ring the bell to be notified when I'm live, and I'll be live most likely tomorrow. So I hope to see you then for Broadband Deployment News. Take care. Bye-bye.